Imagine a world orbiting Jupiter, Europa, a smooth, icy moon. Beneath its frozen shell, scientists believe there's a vast, salty ocean, possibly twice as much water as Earth. Jupiter's gravity creates tidal heating, keeping this ocean liquid. With water, energy, and essential chemicals, Europa could even support life. That's why space agencies are planning missions to explore this mysterious ocean world. How do we search for life on Europa, buried under miles of ice? Drilling is tough, but nature helps. Plumes of water vapor erupt from Europa's surface, carrying ocean material into space. A spacecraft can fly through these plumes, collecting samples. We're searching for biosignatures, complex molecules like amino acids or fatty acids, the building blocks of life. We're not just dreaming. We're searching for life on Europa with robotic explorers. NASA's Europa Clipper and Europe's JUICE are on their way to Jupiter's icy moons. These spacecraft are packed with instruments, like SUDA and mass specs, to analyze ice grains and gases for signs of life. Working together, they're like detectives, searching for clues in one of the most extreme environments in the solar system. The first hints could open a whole new chapter in our cosmic story. So, let's imagine the moment. The data comes back from Europa Clipper, or JUICE. After years of careful checking, scientists announced they have found strong evidence of microbes in Europa's ocean. What would that mean for us, here on Earth? Simply put, it would change everything we thought we knew about our place in the universe. For all of human history, we have looked up at the stars and wondered if we are alone. This discovery would answer that question with a resounding no. Life would not be a special miracle that happened only once on our planet. This would tell us that life is not as rare or fragile as we might have thought. It would prove that life can start and survive in conditions that are very different from Earth. Life on Europa would not get its energy from the sun like plants do. It would have to use chemical energy from its rocky seafloor, in total darkness and under immense pressure. This would mean that the habitable zone around a star, the narrow band where liquid water can exist on a planet's surface, is not the only place life can thrive. Life could be hiding in the oceans of countless icy moons all across our galaxy. A discovery of life on Europa would ignite a new golden age of exploration. Scientists and engineers would immediately start planning new, more ambitious missions. We would want to send a lander that could melt its way through the ice to release a submarine into that alien ocean. We would want to see these life forms with our own eyes, study their DNA if they have it, and understand how they live. The focus of our search for life would expand, looking for similar ocean worlds orbiting other stars. It would be the most exciting scientific quest we have ever undertaken. Ultimately, finding even the tiniest microbe on Europa would connect us to the cosmos in a way we have never been connected before. It would show us that the universe is not empty and sterile, but is likely teeming with life in many different forms. It would be a profoundly humbling and inspiring discovery, reminding us that we are part of a much larger biological story. We would no longer be just Earthlings. We would be one of at least 2 known life-bearing worlds. And that would change how we see ourselves, our planet, and our future among the stars forever.